All right. Welcome to episode 3 of Tacit Talk. My name is Connor, your host, and today with us we have our third guest, Elias Mårtenson, who is the creator of the Kap programming language. And I think we're going to start off by asking Elias to give us a bit of a background because I will link everyone. I believe it is in the description, in the not show notes, but description of the YouTube video. But it'll also, for the audio listeners, be in the show notes. Link to Arraycast episode 72, where we interviewed Elias before. But I don't think we fully went into your background in programming because I know outside of being the creator of an array programming language, you have dabbled in other languages, functional languages. So maybe I'll throw it over to you and you can give us a background in your path into array languages and cover your stops and different paradigms along the way. I think you are muted.
Sorry, can you hear me now?
Yes.
Yes. This button, this mute button needs to be careful with it. All right. Oh God, but all right. Since you asked, I guess we go all the way back to ancient prehistory, before you were born, I guess. Back to must be 1984-ish, around there. With the Commodore 64. So Commodore 64 Basic and subsequently assembly on 6502 assembly on that one. And I used that for a bunch of years. I started programming before I got my first computer, so it's probably 83. I attended a basic class because my parents noted that I liked computers, so they figured, how about learning? And then they had to buy me one. So I got a Commodore 64 until I moved to the Atari ST. And on that one, there was 68,000 assembly and some more basic on there. And some friends' PCs. I was doing Pascal and then C. And then what was after that? Then it was more C, some C++ when that started, and did a bunch of Perl after that when I started working, and then moved to Sun workstations, Java very early. I started working for Sun Microsystems back in, that must have been 97. Yes. So it was a bunch of Java there, and more C++, because I was doing developer support at the time. I'm thinking about all the programming languages I have been exposed to. Oh, I did a whole bunch of TCL. I remember that, or Tickle. That's what the fanboys wants to call it. But me, I could never. I don't know. Maybe it's because it just, the word sounded weird, so I've always called it TCL. So I did that on back in the mid 90s. Shell script, of course, all the time. When working with Sun machines, I was doing Spark assembly because, debugging complex problems sometimes required me to drop into assembly. Then around there, I started doing Lisp and Scheme, and since and then I was also a member of a computer club where that was Unix focused. This was also mid 90s, and on that one, I remember one of my first days I was hanging out there. I wanted to write some C code on this Unix machine, and I had never used Unix before, but I learned that the CC command compiled. But I needed to edit a file. I needed an editor, so I asked the guy who was there, and he said, yeah, there's an editor. It's called Emacs. Okay. And he showed me how to start it and said, okay, you're on your own. Well, I mean, you pulled into it, right? So that forced me to learn not just how to use Emacs, but of course Emacs Lisp as well. And this becomes important shortly, I think, because it ties into APL a little bit. And this is also the club. I think I mentioned it in the previous in the podcast before, that this was the club where they had that APL keyboard lying around, where I learned about the existence of APL. But as I mentioned, people tried to get me to be scared of it by saying, "Oh, this is a scary thing, and look at the symbols. Oy, oy, oy. You can't. No one understands that." And called it all kinds of weird things. But yeah, of course, that made me interested. Anyway, fast forward a little bit, a bunch of other stuff. I mean, I've done small talk and and Elixir and some Erlang and I've lost count, lost track, a bunch of stuff. Clojure as well, of course. If you search on YouTube, there is a presentation where I demonstrate how to do Clojure and Common Lisp development in Emacs. Anywho, fast forward to around the release of GNU APL, I think. I mean, when I learned about it, which wasn't that long after the first version was released, and I got my hands on it, and I realized that okay, finally, after all these years, there is an APL I can actually play around with that is not commercial, that is completely free, but it lacked editor integration, specifically Emacs integration, and if you lack that, then you have to write it yourself, which I did. So if you go to Melpa now and download the Emacs integration, that's the GNU APL mode that I wrote several years back. Yeah, so that that's the long story, or short, depending on what you want to compare with. But so I think how I got from GNU APL to developing Kap, I think I mentioned in the podcast. So I don't know if there's any reason to repeat that, but to very briefly, I was using GNU APL. I liked it. I had some issues with it though. I wanted to extend it, change it to be more something I like. I wanted some extensions. It had some limitation that I didn't that I believed that I could fix. But the goal in the GNU APL community is much more traditional, so to speak. They want to keep the APL2 compatibility, which I didn't care for at all because I don't have any history with it. I wanted first-class functions. I wanted, structures like for loops, while loops, and things like that, because I figured that it should be possible to take APL for what it is, but on top of that, add the kind of programming style that is popular today, structured programming. And why not add it? Why I figured that perhaps I mean, while it's certainly possible to describe any type of computation, any type of program using pure APL syntax, there certainly are cases where a while loop is nice. There's nothing wrong with it, so why not add it? And I realized that I didn't. So I wanted to experiment with that and a bunch of other things like lazy evaluation and things like that, and which I did experiment with. But then I realized that I didn't want to fork GNU APL. If I was gonna fork it, then I might just start something from scratch, and that's what led me to start developing Kap, based on a few fundamental design principles, if you like, which was I wanted it to be possible to write code in a traditional way, if you like, for loops, if statements, that kind of stuff. I wanted lazy evaluation, which we might talk about later. I wanted it to um, um, well, I mean, fundamentally, there were those two things. And I also wanted it to be possible to write code if you didn't know anything about APL and how it works. It should be possible to write a program in, Python style, if you like, or JavaScript style, and it should be fully readable to anyone who only understands those languages. And my ambitious idea originally was that maybe it should be possible to write the language such that you introduce them to the language by just using traditional programming structures and then lure them into the array programming style afterwards. That idea completely failed. I don't think that's feasible. I don't think that's a feasible idea anymore. It was an experiment, but I think to start using a language like this, you have to be in on the idea of array programming. Luring them in that way I don't think doesn't work. There's no reason to. You have Python there, it's fine. They're going to be using it. You have to be interested in it. So, but because I had those ideas, the features are still there. These if statements and things, and they work nicely, but they work to help, in my opinion, bring the language to be more flexible rather than as a tool to bring in people who are not wouldn't otherwise be willing to learn this type of programming. Yeah, so I mean, yeah, you asked about my history. Yeah, that's my history plus the history of Kap, I guess.
So I guess, yeah, I'll ask a couple questions that I've been, compiling on a stack in my head. The first one was I didn't realize that it was the appearing of GNU APL that basically like unlocked your ability to go explore it. And it makes me think that like the importance of not necessarily the open sourceness of a project, but the ability to go and test something out. Because am I correct in understanding that up until that point, there was no interpreter that you could get your hands on just for like freely available online?
There was. So I had for years until the episode, from the episode with the keyboard, where I realized that, and I read some things about it. But remember, this is probably early 90s where I saw that and I learned of its existence. And, I didn't have much material, especially back then. You would have to need to find a book or something. And at the time, I wasn't interested enough to go out looking for a book. But if information landed in my lap, I would certainly use it. So I would say there were 3 different versions of APL that I was playing around with during different occasions. So it was A+, which worked, but was a huge hassle to get to run because this was pre-Unicode. I guess Unicode existed when APL plus, so A plus was introduced, but if I said APL plus, I meant A plus. But it was hassle to get to work. You needed special fonts, and the encoding with getting it to work in Emacs, nightmare. But it was a fun to play around with, at least. Then there was the IBM APL2, which at the time had a demo version that had some limitations, which I can't remember, but you could use the entire thing. Unfortunately, it was on Windows, and I am not the person who likes to use Windows much unless I'm absolutely forced to. But once in a while, I rebooted into Windows to play around with. Likewise, the same went for Norse 2000, which was, I think, the most complete and interesting implementation. But again, Windows only. People tend to, at least at the time, and I'm sure still, use Norse 2000 using Wine, and that supposedly works fine. I still, I didn't, yeah, it didn't, it was enough to play around with, but nothing I could really contribute to, because then that means programming for Windows and stuff. And early back then, when I started looking at this stuff, Dyalog was also difficult to get your hands on. I think if Dyalog had been, if I had been aware, I'm not entirely sure when Dyalog became freely available. I mean, it's not open source, but at least it's freely available and very flexible to use, and has a license that allows you to do pretty much whatever you want, but until you make money from it. That's my understanding.
Mm-hmm.
I guess I would have played around with it more, but then APL showed up, and it was like, yeah, this is great. I mean, it's open source, Linux, friendly community, a maintainer that was very happy to take my patches that I contributed very early on. So why not? Yeah, and I wanted to mention the third thing that was a sort of a principle that I wanted, which is not directly related to the language, but I also wanted an environment where the number one question I felt I saw on the GNU APL mailing list by people who were learning the language was that, okay, I've gone through the tutorial, I know the basics, and now what? How do I get my data into the system? And GNU APL's at least at the time, the IO functionality was somewhat, shall we say, archaic. Very annoying to you had to do pretty much everything yourself, and if you wanted to read a CSV file, it was a hassle. Which is why when I built Kap and I started building the UI for it, I wanted to make it really easy to pull data in, so you can just import Excel sheets, you can import CSV, and you have an editor you can do. Some of that is implemented in the GNU APL mode, but I realized also that it's a little bit stupid that to integrate data import functionality in the editor integration. I did it because it was easy, but so I wanted that to be an integrated environment when I built Kap. So which is I think if I'm not mistaken, I think I on my YouTube channel I put up a couple of videos showing how to import and export, or at least import Excel and how Excel integration works.
Yeah.
And I shouldn't say Excel because it integrates any. You can import LibreOffice as well, of course. So, yeah.
Yeah, we'll link. I think one of your, if not your most recent blogs on your blog, is about a comparison to kind of Excel, and I think that is
Yeah.
one of the things that Kap sets itself apart from the other array languages. Is it does have like an Excel-like kind of UI for interfacing with your tabular data, which obviously you can do that in the editors of APL and BQN, etc. But it doesn't have the Excel feel to it where you have a little cursor and you can like drag it around and do stuff like that.
Yes. So I wrote that post to try to explain. Okay, so I work today with people who love to use Excel. There's a lot of Excel in where I work. So I see people use Excel in all kinds of ways, and some ways in which it is used is absolutely amazing. I mean, people do crazy cool stuff with it. The thing is, though, some of the things that they do with Excel should not be done in Excel, because it is great for data entry. It is also great for data presentation. It is absolutely terrible for computation, because it will not tell you if something goes wrong. It will just, everybody knows about the problem of something that happens to be parsed as a date, and then you have a date field in the middle of your numbers or your strings or whatever, and those problems ends up being hidden until they give you wrong data and you don't know. You can all of a sudden get the wrong data, and so and nothing warns you. And there has been several cases of scientific research coming to a completely wrong conclusion. I think during COVID, the UK government lost 2/3 of their. They simply didn't include 2/3 of the cases in their statistics, which shaped their COVID response. potentially harming actual humans. And I don't think a mathematical tool or a tool that purports to be mathematical should do that, right? So I figured that, if I can somehow build a tool where you can work with the numbers in the reliable way, and then why not use Excel for presentation? And I want, or LibreOffice for that matter. So something I do have on my to-do list, and I've started working on, is more live, real-time integration between the tools, so that you can go into your spreadsheet and you can create a presentation based on data that is actually living inside Kap. I'm working on that. I have some prototypes going. The main problem there is that the LibreOffice API to talk to a live instance is quite horrible. It is. Let's put it this way: the documentation for the API has an example where you have to do some currency conversion, and the currency includes Deutschmark, which, as we all know, was changed to euro sometime in 2001. I don't know, which means clearly the documentation hasn't been updated since then. Or is it 90s? I can't. 99. It's 20 over 20 years, right? Now the Excel API is actually much nicer to use, but it's Excel, it's Windows. But I will do it. But I have a lot of ideas there. But so hopefully something will come out of that.
Yeah, it's really. I've seen some of the videos too, and correct me if I'm wrong, but it also has a similar functionality to Excel and potentially LibreOffice, where you can point it at like an HTML page, and it can scrape the tabular data from that page. I think I recall seeing something like that.
Yes, yeah. So you can copy and paste HTML, and it will identify automatically tables, and then it will do. Then it will parse the content, because it is in table fields in HTML. It is text, so it has to use some kind of heuristic similar to what Excel does, but it will display the data for you first, so that you can actually check that it's been processed correctly. And if something gets processed as a string when it's supposed to be a number, say, you will at least be told about it rather quickly and drastically when you get an error later. So it's meant to be more reliable than Excel.
Yeah.
Because so that stuff is quite easy. I mean, you just when you do copy and paste, you pull it in as HTML, and then you use something like what is it called, tag soup, to just pull it in as a structure, and then you read the data. So that's the easy part. Parsing it with heuristics, that's the somewhat trickier part. It works quite well. It works on Wikipedia data, which is the most common source of tabular numbers that you can find. So that's good, I guess.
All right. So the next question, and this is something I've been thinking about a lot in the past couple weeks, which ties in well. So I mean, to recap, Kap is a open source APL that's inspired by GNU APL, and I think in Dyalog APL in some ways. Functional, first class functions. You added some stuff like laziness. I don't think you mentioned it, but there's like parallel operators. We might talk about that later. And the second thing that you mentioned, which is the third on my list, is this kind of control structures and the ability to do programming as it is known, in the large in Python and JavaScript. And was trying to solve this problem in the last week, and I solved it in, I don't know, less than 10 minutes in Python, and then spent like a good 2 or 3 hours failing, and I still have not solved it, because the way that you solve it in Python is just by repeatedly updating a dictionary with based on the current state of the key value pairs, and then based on that you do something. There is a way, I am positive, to map this to like a scan that has some kind of state in the accumulator, and that was what I was like pounding my head against the wall for 2 or 3 hours. But it did make me kind of realize that like I'm not a novice array programmer. And I am smashing my head against the wall, trying to squeeze this problem that is super easily solved in this other paradigm into this array pattern. And maybe I am just not like an array programming expert enough that there is actually a cleaner mapping to some other things. So I'm interested to get your thoughts on like what your experience with Kap is, that you have both of these paradigms, and like how often do you end up reaching for the easy Pythonic JavaScripty way of doing things, and how does that like change the language as an array language?
First of all, I'm not so sure I would just say that the imperative style is necessarily easier. It can be easier. And certainly, if you have something where you have, if I had a problem like you were describing, right? You have something where you push stuff into a hash table and you loop over it, then write it like that. I write it like that in Kap. You have hash tables and you have for loops. It's fine, right? Maybe I would use the power operator to avoid the for loop and just do it like that. But you have hash tables and they convert back and forth between regular table and hashes. The hashes are immutable, by the way. So when you update the hash table, it returns a new version of that table. So it's in same as Haskell basically, and other functional languages like that. And to me, there's nothing wrong with that. There are certainly times when I disagree with the prevailing opinion of at least part of the APL community that says that, oh, hash tables are bad. You can just do it with the tables. Sure, you can, but it does not. That doesn't really jive with the way I think. Right? If I have a map that maps some values to another values, and maybe one of those values is another map, I want to represent it like that. I don't care if there's a way to represent a tree using an array with numbers indicating the level. Some people like that. I don't. And my personal belief is that if I don't like that, I shouldn't be forced to do it that way. And I don't, because there's nested there's nested arrays in APL even. And so even if I do something in Dyalog, I use nested arrays. Hashtag very often, in if I were to do that in Dyalog, with a map, I would probably use a 2-column table, right? And you just key values, and then I would just accept the fact that that's probably going to be significantly slower than using a hash table. But that's fine. It's so rare that I use such massive data set that performance difference even matters. But in Kap, I would just use the regular hash table because it's there and it works. And that is what I'm struggling with too when writing my, because I've been working on writing my tutorial for the language. And on one hand, you want to explain that, look, you have this seemingly complex problem that you can solve with 4 characters because you think about it this way. And it's really nice and it's really cool. And once you know it, it's like beautiful. But a lot of people don't know it. And getting over that initial hump can be incredibly difficult. And I don't want to scare people away, because because presumably when you try to solve a problem like that, that's not the only problem you have, right? You start, you want to build something in a programming language, you start, and it's a series of problems after problems after problems, right? I mean first you have to compute something else, and compute something else after that. Now if you're halfway through your program, you built a bunch of stuff, and now all you want to do is to put stuff in a hash table, you're going to be janked out of the flow if you now have to start to think about a completely different way. Nothing wrong with trying to figure out a better way to do it, but in the moment, you probably just want to get going. So the functionality should, in my opinion, be there. And now I'm gonna be controversial again by saying that there's one thing about Dyalog that I believe. I don't know if it's intentional, but I get the feeling that in Dyalog you're a little bit punished for not doing it the correct way, right? And for example, using while loops in Dyalog, they don't work all the time. I don't think they fully work inside of if you in a defun. Why can't I use it in a defun? I mean, I know that there are technical reasons why not, because it has to do with its historical reasons. It's
Mhm.
because of the way Dyalog is implemented, and I don't think they did it intentionally. But when you use it, and when you say, "Oh, I just want to get this over and done with a loop," you kind of feel that you're being punished for having the audacity to to want to use a loop. So that's sort of one of the reasons I wanted to add this stuff as a friendly gesture to people who just want to get things done. So I think if you take a look at some of the example code I have, like in the standard library, I have the entire the renderer that displays, that takes a Kap array and displays it in character form using box drawing characters and stuff. It's written in Kap, and it's written in a style that is a mix of unreadable line noise and nice easy to read the structured code, because that's the way it was. I mean, that's simply how I chose to write it, and I think it's fairly readable. But you have to understand the language quite a bit to do it. But still, I mean, it's written in. It's not written in the absolute most code golfed version, which I could have, but I chose not to because I figured that the standard library is probably a place where people will look for examples. So I wanted it to be nice that way. So I mean, if you want to get an idea of where I where I stand there, you can look at that code. Now I had a point that I wanted to get to that I completely lost track of because I went on a tangent after a tangent. You are not the only one who does that. But I'll reconnect to that later.
Okay, yeah. If you think of the point, just interrupt. But I mean, the one thing I will comment on, and then I'll ask a question, is I totally agree that I have at times been programming in Dyalog APL, and I prefer to program in like a defun only style. It's I think promoted by, I believe it's the Carlyle Group. It's the company that Josh David, who now works at Dyalog as a consultant, he used to work for, and they have a lot of their libraries. Like Excel conversion libraries and a database library. It's all on GitHub, so you can go and look at all the Dyalog APL code there. And they have a specific style. It's really nice, short variable names, defuns only. But then if you try to do that defuns only coding style, especially if you're doing like some of the simplest, I remember I think there's a learn to code in Racket book, and they have a series of games, and the first one is like a number guessing game. So like the actual APL code there, it's like less than 5 symbols. And then the rest of it is just like input, output, looping around until you get it. But you actually can't do that in a defun. You have to end up doing something recursively if you want to use a defun. Otherwise, you have to use the del functions that like I don't think I've actually ever, like, I just don't like to program in that style because it feels very, I don't know, just weird compared to like a defun with closing and opening braces. So I totally agree that I forget that, like, oh yeah, I want to use this if for this while, and then you can't, and then I kind of I switch to a language that like BQN or something that will let you do it, because it's just it does seem punitive in a way.
Yeah. I certainly wanted to. I wanted the structured programming constructs to be on an equal footing. Now, of course, a while loop is going to be much more big and clumsy compared to a neat reduction or something like that. But I don't want to put them, against each other. Sometimes you want to have a loop, and you know what? When you do a loop, you probably want it to be visible, and you want it to be very clear that you're actually doing the loop. So actually calling that while, having while, and then within parentheses the clause, and then the things within braces is fine. I'm not a purist in the sense that, oh, I want everything to be as short as possible. The I was thinking about this actually last week. I when I was lying in trying to fall asleep, but due to jet lag, I was still awake. So I started thinking about how I could, because I suspected you were going to ask something like this, right? So I was trying to think about how I what is my view on writing very terse code. And I realized that there are actually sometimes people see a very beautiful, elegant line of APL that does a lot of stuff in very few characters. And sometimes these people say, oh, this is write-only code. And you know what? I realize that they're not necessarily wrong, because the absolute majority of Kap Code and Dyalog, for that matter, and J, I've written a bit of J as well, and the vast majority of code that I've written in these languages is write-only, because I use it in the REPL. I use it, I have a problem, I just want to calculate something, I type it into the REPL, I get the result, and I'm done. It scrolls off the screen and it's done. No one ever reads this code. So when you have a calculator, you want to calculate 1 plus 2. I want to be able to type 1 plus 2. I don't want to define a function that computes 1 plus 2 and then call the function, which I probably have to do if I want to do it if I want to do it in Java. I definitely have to define a class and then a function just to calculate 1 plus 2. It's crazy, right? You wouldn't do that. So I realized that there is a spectrum starting from the absolute simplest calculations that every language that has a REPL can do in a few characters, which is simple addition, subtractions, whatever. And then as the problem grows in scope and the more complicated problems you want to solve, the longer the command line becomes. And once your program is longer than a couple of lines in the REPL, at that point, that's when you go to a file and you start to write a real program, right? So if you, and so the goal, at least with Kap, and I'm pretty sure that any APL program would agree, and J programmers for absolutely for certain, they would agree that the goal here is to allow a programmer, or is a huge benefit if a programmer can solve their problems without actually having to write a program. If they can just, sorry, I have a cat here. Sorry, go. I would show her, but she hates being carried. So yeah. Anyway, okay, I'm gonna carry you. Okay, so I'm gonna show you to the audience.
Look at
Hello,
this.
say hello to the kitty. All right,
First
there.
ever kitten on the Code Report YouTube channel.
Yeah, yeah. So the point is that if your language allows you to be very, very expressive with few characters, that means that there is a much larger set of problems that can be solved without writing a full program. Right? You do it in the calculator. You do it in write-only mode, so to speak. Now, if you design your programming language in a way that forces the programmer to not be concise, Go is a very good example, then the number of problems you can solve on the REPL is very small. So there is a conflict here, right? Either your program is really, really expressive, but then it becomes possible to write unreadable mess. Or you prevent unreadable messes, but then you have to write many more programs because your REPL is not going to be as powerful anymore. Right? That doesn't necessarily mean that the program that you write in a file has to be just as unreadable and difficult to understand as the things you write on the REPL. It's just that it means you have the ability. Now, what that means is that if you have such a powerful language, flexible, expressive language, you have to have more discipline when you write code that others should read. So my point, the point I'm getting at is that the people saying that these things are unreadable and are write-only are not necessarily wrong. I mean, of course, it's much more readable if you know the language. I'm not saying they're 100% correct and that APL is an unreadable mess. No, it's not, but it can be. It's just that it's much easier to write an unreadable mess in APL because it's such an expressive language, right? The more expressive your language is, the easier it is to write stuff that is hard for other people to understand, which is why Go looks the way it does, because they had a different design criteria. They wanted their language to be, they wanted to be very difficult to write, to be clever. But in array programming, clever is what you're supposed to be. That's what makes it nice. That's what makes it fun to use, you see?
Yeah. I totally
So
agree. Like what you're saying, it goes in line with something that I have always kind of felt to be true is that like I lean to the shorter leak codey, you know, coding interview coding challenges that are always solvable in like less than 10 characters in an array language because that is where like array languages, maybe for better or for worse, they're at their most beautiful and elegant. It's when you're not, you know, doing quote unquote real programming. You're just doing this concise little thing that's using a scan or a reduction or some kind of modifier or operator. It's 6 characters. Anyone that knows the array languages can pretty quickly like read it, figure out what it's doing, and like the elegance of the solution is apparent even if you aren't even an array language programmer.
yeah,
But there's this dichotomy, if you will, like this conflict that you mentioned that like when you get to real programming, you can't I mean, you can, I guess, if you're Aaron Hsu, which I was going to mention him earlier because Aaron, you know, Code Defund's author, and he has a very dense style of writing APL code. And he also has this talk. I'll link it in the description later and the show notes of the audio podcast called like I think it's called anti-patterns or patterns or something like that. And he goes through 10 things, and one of them is idioms versus libraries. And he argues that like APL encourages you not to have libraries. And like I can't, even if APL does encourage you to know your idioms, I don't want to program without libraries. Like I don't want to have to go program the world if I want to do real programming. Like I don't want to have to go write my own, you know, importing from Wikipedia table converter. I want that to be like a one-line thing that I just call that someone else wrote, and that's the power of Python. Python, a lot of the times you don't have to write the code, and sort of it's what you're saying is that like, you know, and you also mentioned hash maps. I was going to ask like, do the hash maps do they come with symbols, or are they all like library kind of the Python-y JavaScript keyword code?
well, let's see if I can.
Oh yeah,
Let's
we
see.
haven't shared screens yet. If we want to
Yeah, I
share
can.
screen at this point,
Yeah, I can show, because the thing is, um, I've seen the talk that you mentioned, and let me just see if I can. I think I have to share the entire screen here, like that. Um, I've seen the talk, and I understand what he's saying. I am not entirely sure I fully agree with everything he says, and you know what? I think that's okay,
it's totally okay
because
to disagree. Yeah.
um, because you know, I don't have the kind of array programming history. I didn't grow up with it. I mentioned a whole bunch. I lost count how many programming languages I have used. Right.
Mhm.
I've you know, I want I so I don't think I'm biased. Well, I do have biases. I'm very biased against Python for various reasons, but that's an entire different. I could spend an entire podcast talking about the reasons why. But I you know I respect people who use it. It's not like saying that people that use Pythons are idiots. It's just that I personally, it doesn't, you know, it doesn't fit my uh, my style
Mhm.
of programming. So what I'm saying is that, but different. That's another case where you have different people have different opinions about these things. Um, which of course shapes the design of Kap, right? Because I am probably not going to take so many ideas from Python because I don't use it. I take more ideas from Lisp because I use it a lot. Now, I don't know if this is readable, because is this too small? I don't know if I can make it
If you can make the
bigger.
font, I can read it, but it might be a bit better if you can
I
increase the font a
the
bit.
problem is I'm not sure I can, because there's a bug in my in the tool. You know what I can do though? I can run the text-based version. It's slower. The native Linux version is slower, but it's fine. We're not going to do anything high performance anyway. So that would be thanks. Sorry, I have to build. Sorry, build.
No
No.
worries. You're getting What do they call it?
Oh, I didn't build it. Oh, shoot. I thought I did. Fine. Sorry.
Worst case, we can use the GUI.
No, it's fine. I think we just did our text client, and we just have to do link release executable.
And for those that haven't listened to Arraycast episode 72, I guess we should have covered that at the top. Kap stands for Kotlin APL, and I believe what we're looking at is the JetBrains.
Yes, exactly.
IDE.
And now someone is grinding their teeth and said, "Didn't you say you was an Emacs fanboy?" Yes, I am. Yes, sorry, but Kotlin I write in this tool for various reasons. It's very difficult to write Kotlin using a different tool, so it is what it is.
I mean, I'm sure it's possible, but like JetBrains, the company, created the language Kotlin specifically to work amazingly with their IDE. So it would be a big mistake not to.
Yeah. So while this compile, I can explain that the tool itself compiles to JV. It had the main UI is in using the JVM. So compile to JVM, but Kotlin allows you to compile to native and to JavaScript and to WASM as well. So there is a web version. So when you run the web version in the browser, it's using the JavaScript version. It runs completely locally on the browser. There's no server-side component at all. Other than a regular web server that just serves the JavaScript. And the native version compiles to Linux, and that I have not entirely. I'm using a different laptop that is quite slow, which is why it takes a little while for it to build. Maybe I can run the GUI for now. Okay, so let's wait for a brief moment while it is okay. There we have it. So if we look at you were asking about the hash table. So a hash map is a scalar object. So you have a function called map that generates it, and it takes a pair of values, right? So we can have key A with a value 10. With a colon, a name with a colon is a symbol. Anyone familiar with Common Lisp has seen these before. So these are symbols in the first-class symbols in the keyword namespace. And the reason you want to use them is because they are very fast. You don't have to do any string comparisons in any way because they have an identity by itself, which is unrelated to its name. So lookups are incredibly fast. So it doesn't have to do string comparisons.
And that's the same enclosure, right?
Yeah. And Lisp introduced that idea. Now, there's nothing that stops you from using strings as keys, of course. But normally, when you just do it like this, you want to use keywords. So we can create another so the key B, and then we put the string in there, hello, and ABC, a third one, which contains a number 1, 2, 3, 4. Like this, right? So this creates a map with 3 elements. So we can assign that to a variable q, and we have a function called a map to array that renders it as an array, 2-column array with the fields. So then you can use to look up. You can either use map get, which just looks like this, and then you can say ABC gets the value, or you can just do like that. So to modify a map
for the audio listeners, like that was using the bracket indexing.
Yeah. So a Q bracket and then a symbol inside, a value inside, and that will just return the value just like any other array lookup. To modify it, I would then, if you recall, I said that the hash maps are immutable, which means that I can do W assign Q being the old map, and then I have a function called map put, and then let's say I want to add another element, test 1, 2, 3. And this then creates, so W is now an updated map that contains the same values as the previous one, but another field. Sorry, Q is still the old one. So map to array, W will then print this one. So yeah, yeah, that's really all there is to it. It's quite easy to use in that sense. Now, the renderer of the code that renders the array. So you have the array here, and it renders the content using box drawing characters. That code itself uses hash maps in a particular way that we can open the code for that guy, which is here, standard lib output, and we have here a hash map that is initialized here. And what it is you have a variable called type to formatter that contains a map where the key is a data type and the value is a function that is responsible for rendering values of that type. And if you change, so you have a function called render number.
Is that what the lambda does? It indicates that this is a function?
Yes. So lambda, so if we, let's see, did it successfully build? Okay, it's successfully built. That means I can now maybe make the font a little bigger by using this here. So we can do text client. Let's see, make it big like this. And you should build bin there. Oh, we have to specify the path to the standard library, standard lib. All right. So a function reference looks like this, right? So you take the lambda symbol, and then anything which is a function in APL, I mean a plus, right? Plus is a regular function. So again, if anyone listens to audio, it's just the symbol lambda and a plus, and this returns a function. You can create an array of these, so you can have lambda minus or lambda, I don't know, lambda sign. Oh, sorry. So this is so now I have an array of 3 functions: plus, minus, and sign. And if I assign that to a variable, then I can say, and then I can use the apply function, which is the symbol to apply a function, because now I have a list. The functions are an explicit object. You have a first class. It's a scalar object, works just like any object. There's nothing magic about it. I know in J, for example, and also in Q, you can have function references, but in the syntax of the language, if the function name shows up in a context where the function where it looks like a function call, then it's called, right? So if I assign, say, Z from Q0, now Z is a function. So I type Z, it tells me it's a function. And if I type Z10, now in some other array languages that has first class functions or some variation thereof, in this case, if I just type Z space 10, that would call the function Z with the argument 10. In Kap, that's not the case. It just strands it into a 2-element array. The first value being a function and the second value being 10. So I have a 2-element array with a function and then the scalar value 10. So to explicitly call a function, I have to use the apply operator, which is not an operator; it's a symbol. It's special syntax, which is the quote quad, because IO is done in a different way in Kap, so that symbol happened to be available. So you do that Z, and that means take whatever is in Z, convert it to a function, and then call it. So I can do it like that. And this happens to be the function plus. So of course, plus 10 just returns 10. But and it also has, since the language has lexical bindings, you end up with you end up with the capability of doing full-on closures and closing over functions and closing over values and things like that. So yeah, it's full-on, functional programming in the style of Haskell or Lisp or whatever. And I believe Kap to be, I want to say, is the only language, the only array language that has all of that. Maybe.
I was just thinking that in my head. Like, I know Dyalog APL is nowhere close to having this kind of functionality. BQN, I know you can put functions in a list like you did above with the lambda plus, lambda minus.
Mm-hmm.
But yeah, I would have to ask Marshall if once you extract a function out, I would assume as soon as you put it next to something, like the idea of function references, I know BQN, I'm pretty sure BQN doesn't have.
Well, it does in a way, but I have to admit, I didn't fully understand how it works. So I think if you bring him on again, please let him counter my statement that it's not as fully. I want to say that it can do it, but you have to. It's slightly different. I'm pretty sure it doesn't do functions. You can't convert the function to a scalar unless you enclose it somehow. I don't know what happens if you do enclose on a function object. That's something for Marshall to explain.
Yeah, potentially it has to do with the switching of roles, right? Because depending on how you spell a thing, it assumes a different role. So
I clearly should. I clearly should.
This is super. I mean, we'll get back to the HashMap code that we were looking at in a sec, but this is really neat. And it also, like, this is the kind of thing that if 1 month ago Connor had seen this, I would shiver at the math colon sign because it's asymmetric. Plus and minus get 2 symbols, and then the sign function takes, what is that, 8 characters? 4 for a namespace, the colon and sign.
You don't have to. You can import the math namespace and then you can type just in.
But now, like, this is the thing, is that, like, once, I think that was because 1 month ago, Connor, he really, really tended towards just the elegant, less than 10 character single solutions. But now that, like, one of my goals for 2024 is to, move past that and actually see, like, do I love array languages even when you are doing quote unquote real programming, where you need to start importing libraries, using namespaces. A certain percentage of your program is going to start to look more verbose. Like, if I've seen a lot of Marshall's code that he's done for large projects, and, like, the symbols are scattered everywhere, but there's also a lot of function names and things that are imported and things that aren't symbols that are, spelled out variable names and function names. And now when I see this, I actually think it's quite nice because, like, what's the equivalent of sign in Dyalog APL? Isn't it like it's the circle function?
Circle 1.
Yeah, with 1, 2, or 3, which I never remember.
It's one circle, so it would be this.
Yeah. And
so if I want to take the sign of 1.9, you would write it like this. 1 circle 1.9, while in Kap it's just like that.
And then you get into a philosophical discussion of, like, obviously I think all array programmers agree learning what symbols, operators, functions, what the symbols mean, it's important, it's necessary. But then as soon as you start getting to functions, especially in J, like J has the P colon and the Q colon, which are like prime functions, like P colon takes 10 different constants on the left, which then permute the, what is it, like, given a Boolean vector, convert, it to the first, second, third, and fourth prime, or, like, calculate the 42nd prime. So depending on the left integer argument, you have 10 different flavors of your prime function. And that, I think, it's like a lot, not many array programmers are going to agree, because, like, are you always going to memorize what 7p colon does? Whereas, like, if you read math colon sign, everyone knows what that means, right? At least if you're familiar with math.
Yeah. So someone, maybe it was Marshall, probably Marshall or Sama, that calls those functions Trechcoat functions, where you have a symbol that you have a whole other bunch of functions hiding in a Trechcoat. And my understanding, and probably someone is going to correct me, and please do. But my understanding is that there were technical reasons why they chose to do it that way back in the olden days when APL started out. There was something that prevented them from predefining functions, primitive functions and operators using names. It had to be symbols because names were parsed in a different way. It had something to do with the implementation. And which is why you ended up with the circle functions, where the left argument to circle indicates which function you want. So it's sine, cosine, tangents, the hyperbolic functions, and a bunch of others. You have the I-beam functions. You have in J, you have, as you mentioned, you have that system. What is it? It's an exclamation mark something.
Oh, for functions, yeah. It's like exclamation, number, colon, something.
Yeah, that has like 50 different functions with different numbers. Sometimes the numbers has some kind of relationship to what it does, but usually not.
Yeah.
And the problem is that these are functions that are not used very often. I mean, how often do you use sine? I mean, yeah, if you write a game engine, you're going to use sine a bunch, or 3D, something like that. But most people, in most normal programming, you very rarely use the trigonometric functions. So, which means that when you need it, you're going to have to look it up, right? Because you are going to see a number and you're going to say, was this 6? Is that 6? I think is hyperbolic cosine. I think. I have no idea.
Your guess is better than mine. I always even forget like what the first three are. I always have to look it up.
The first three are sine, cosine, and tangents, right? So 4 would be hyperbolic sine, 5 is hyperbolic cosine, and anyway, something like that.
Yeah.
And this just hammers home the fact that it is impossible to remember. And even if you do remember, you still want to double check. And so the functions that needs the names the most are the ones that don't have it.
Yes.
And to be honest, I don't think there are many hardcore APL programmers that would disagree when I say that these Trechcoat functions were a mistake.
Yeah.
And they are a historical artifact. And since I am lucky enough not to have to worry at all about backwards compatibility, I could just say no. I don't need them. I can give them names, and I don't think anyone would complain. I asked on the chat some time ago if someone had a good example of where the left argument is not it's not a constant, right? Because if you type 1 circle, well, that's sine. Are there any case where the left argument to your circle would be a variable? And someone pointed out some example where they had I think they used an outer product with the 1 and 2 on one axis, and then you input some numbers, so you compute the sine and cosine of a bunch of values at the same time. Okay, fine. I can accept not being able to do that. It's okay. Yeah. It's such an obscure. If the benefit is that I can avoid the magic numbers and just have words, I'm all for that. Right?
Yeah.
And so also note that Kap uses the same idea as Common Lisp to create to assign names to namespaces. So if you want to name a variable cos, for example, you can do that because it's in a different namespace. That's why by default you have to explicitly specify math and the math namespace when you want to use it, math:sin, unless you import it and then it gets pulled into your default namespace. That gives you the benefits. You get you get to eat your cake and have it as well.
And so, just out of curiosity, what is the syntax for importing the math namespace so you can just spin and assign
It
explicitly?
is it's up in the air. I just so you can just type import math like that, and then now you can do cos. Now, so again, you said if someone is not seeing this, it's basically import math in double quotes, and then there's a parentheses around the math. It's because, I mean, it's a compiler directive, and compiler directive has the form word and then some stuff within parentheses. The parentheses are completely superfluous there. It's just part of the syntax. I could easily remove it, but yeah, that's the syntax for it. Another thing actually that might be a useful thing to mention is that the while loops and if statements and those things. So you can write if one return 2, else return 3. This gives you 2. So this thing here, the if statement with else, follows exactly the syntax of C, JavaScript, Java, the absolute standard. Everybody should be familiar with it. Now, the syntax is like that because it was defined like that in the standard library. So these control structures are not part of the language per se. It's part of the library. So if you choose not to load the standard library, you don't get these. You can also define your own if you like to have the syntax differently. And for fun, anyone looking at the code here, sorry, looking at the screen here, can see the what it looks like, and that would be in standard library. And then you should have a structure, and the definition of if looks like this. Now, it's I don't expect anyone to understand it right away, but the point is that if you want to have a new type of syntactic element, you can use defsyntax to define them or change them, which is neat, and an idea that I took from Lisp. Lisp of course, uses macros for this stuff, which is a lot more, is much more powerful than the defsyntax capabilities of Kap. But I'm thinking about adding macros as well. Maybe it will come at some point.
Does that extend to Unicode symbols as well? If I wanted
Yes.
to take a jelly primitive like h underdot and borrow that and just define it as double.
Yeah.
I know in BQN because I tried to do that because honestly, there's a lot that I love about jelly, even though it's a code golfing language. And I mean, you mentioned that you watched my most recent YouTube video where I defined h as half. And I was like, I would love to just have this library that just defined all of the, I don't want to say reasonable, but like some subset of the jelly Unicode overdot underdot.
Yeah.
But BQN doesn't let you do that. But Kap
Yeah.
does.
So in Kap you can. So here the standard definition of the key function is it's inspired by the key function in Dyalog, but it doesn't work the same way. It's a function and not an operator, and it doesn't do everything that the APL version does. But the definition is very small, and again, anyone on audio will simply have to go to the source code and look up the file called array/standardlib/base functions.cap, which contains the definition of the key function, which uses the same Unicode symbol as key, as key in Dyalog. And it's just a regular function. You define it exactly the same way as a function, but you don't have to do it for this one, but you can declare a function as being a single character. And what makes a single character function name special is that when the parser reads it, or sorry, that when the tokenizer reads it, it will always return it as a single token, even if there's no spaces around it. So what you can do is you can declare, I don't know, the Greek character omega. Well, omega is already there, but let's say you want to have the Greek character gamma, and you can declare it as single character, and then gamma will just be it will not make a word together with other symbols next to it. It will just be gamma and behave just like any other primitive symbol in the language. And then you just use your the regular function declarations to give it the role, or you can make it into an operator, or even use defsyntax to create a completely new syntactic structure based on these symbols. So there's really no limitation. You can add whatever symbols you want, and so what I've been thinking about doing is create a new namespace, call it Dyalog, define functions with the same name as the existing functions, but living in the different namespace. And this would be Dyalog compatible, more or less Dyalog compatible implementations of those symbols. And then all you have to do is just import or switch your namespace, the default namespace, into that one. And then you would use these alternative implementations of the same symbols, and you would have something, a better Dyalog compatibility. Of course, you still would have problems with Dyalog tacit expressions. You call it Tacit Talk. We haven't talked about Tacit, but Tacit Tacit expressions, they would obviously not. They would still work the way they do in Kap, but the functions themselves could use a strict to change the behavior completely, if you so please. And so you could definitely do it for APL2, because APL2 doesn't do Tacit. And then you could create more of a something very, very close to APL2 compatibility, just just through a library without changing the interpreter at all.
Yeah, this doesn't look to be full blown Lisp macros, but this defsyntax is incredibly it's very Lisp. Like, honestly, it's making me feel like Kap. My mental model of Kap is really, there is a ton of Lisp influence
Yeah,
in the
yeah.
language that is just, it's not at the syntax level, but like behind the scenes, it's really there.
Yeah, so defsyntax basically gives instructions to the compiler or the parser, to explain that tells the parser how to, that here's a symbol that triggers alternative parsing, and then the argument to defsyntax describes the form in sort of a simplified BNF notation, how this expression should be parsed, and then at runtime a function is called, and with a bunch of arguments, and those arguments are themselves function references to closures that closes over the six. Anyway, long story short, it allows you to create custom syntax. So and all of the imperative structures in the language has that, is implemented through that. So there's none of that implemented as true primitives. They're all in the standard library.
So yeah, we don't need to go on a tangent, but I'll ask a quick question, and then you can just tell me yes or no.
Why not? Tangents are great.
Well, because I have like 14 questions in my head that I'm hoping to get to. But so one of the things I've been thinking about is that on BQN, they have the ternary expression equivalent of condition, question mark. I don't even remember the names for them, but like the true case, semicolon, false case. And they put that in braces. It seems like you have the equivalent of that here with the if else,
Yeah.
and the condition in parentheses and braces around your two expressions. Using def syntax, I've thought that, like, I've wondered if any of these array languages have experimented with some kind of fork-like pattern where you could imagine the condition or the predicate that is used to evaluate whether you take the left-hand side or the right-hand side. You could probably could you define some kind of syntax for a tacit ternary expression, if you will.
Yeah, I want to say yes, but the current implementation of defsyntax has a couple of limitations in its implementation. There's nothing inherent in the language in the parser that would prevent it, but the current implementation of defsyntax triggers on the first symbol. So the one thing that is special is the first symbol in the tacit in a defsyntax expression. So in an if statement, it's if. So if you want to have a value followed by a symbol and then another value, that symbol would have to be the.
Yeah, I see what you're
It would be
saying.
tricky. It would be tricky. You can. Yeah, it's interesting. So I think the reason why defsyntax doesn't allow it is because I never needed it. Because frankly, extending defsyntax to support such functionality wouldn't be too hard. It's just that I have never really needed it. So yeah, so unless someone comes up with a great reason why, it's probably not going to happen until I myself have, because I can't really think. I mean, yes, I understand your idea, but Kap already has one function, has half of it. It has, the guards in Dyalog, right? So if we define a function, let's say we call it foo, and we do an opening brace, and then we say omega is equal to 3, right arrow, 9. Okay, and then a diamond, and then we do, for example, then we say return omega plus 100. All right. So if I now call the function foo with the value 8, I get 108. But if I call foo with the value 3, I get 9. Why? Because the right arrow is a function that you can call return. And in the monadic case, it just returns from the function and returns the value on the argument on the right. But the dyadic case takes the left argument as an expression, and if the expression is true, then it returns. So it becomes a conditional return.
Mm-hmm.
And this is the I know it's not a true ternary if, but it covers a rather large subset of cases where you want to do an if and do something, because very often you do want to return something if something is true, and so you do have that.
Yeah, I guess. So I think in Dialog too, if you replace the right arrow with a question mark, does it? I think it, or maybe I'm just mixing up it with BQM, but I think that works in Dialog. But when I see this, what I think immediately is in Kap you have left bound functions, and what I want to be able to spell, like I want to be able to disappear the 2 omegas and just have like a 3 equal 9 separator plus 100, and then like get rid of the braces, get rid of the parentheses, get rid of the omegas, and then
Yeah.
you're just left. But like you would need some kind of extra syntax.
um that depends on what you want to do, because the right arrow is just a function. It's just a regular function. So you could even do something like this, right? You say opening brace, and then you say x assign from, let's say 3 equals right arrow, and then so now we have the function x. So we can now call x, let's see if I get this right, 3x10, and then just return 9 because whatever. And of course something went wrong. Here I was going to show something cool, and I might have actually stumbled across some weird. Why did I get that? Oh, because of that. No.
So here we're trying to assign 3 equals to x, which it looks like that worked successfully.
Yeah. I specify function. This is a defun. I'm not passing an argument to the defun itself. Right. I just have to do something there. Right. So here I should be able to say 8. Why is that? 3 equals to because no. This is interesting. Maybe I shouldn't have tried to demonstrate something that is utterly untested. It's not a good look when you're confused by your own design, right? What have I actually done here? I have created a function that, well, if I do 3 equals to 4, left. Okay, so this is the left assigned function.
Oh, it's three equals in parentheses. The right arrow. So that's the whole function.
Yes, 3 equals to, it's a right arrow. Okay, of course, that doesn't. Okay, that's okay, fine. Yeah, so we want to do this, and so now x is a function that returns returns whatever is passed to the right of x if the argument on the right all the way out here is 3. So this should be 9, but if I make this 3, then it's 4 because I return this value here.
And there's no hope for the audio listener. Just go watch the YouTube video.
yeah, it's because I was trying to be clever so the reason why you would want to assign to return is if you want to if you have multiple nested functions and you want to return to an outer layer because to a certain layer, and then you just preserve the right reference to the return function from that level, assign it to a variable, and then you can use that at the lower level, so you return from a higher scope. It's look at the test cases. I have some detailed test cases that does some stuff there. Basically, you capture the version of return from a higher scope. That might have been a really bad example for a forum like this, because it's something I would need to prepare in order to be able to explain it, I think.
Yeah, it's all right though. I think that the moral or the takeaway point is that you have this defsyntax thing, which enables you not only to create new functions using Unicode symbols, but you can do even more than that, which is a very cool thing to go and play around with.
Yes, so that's the basic stuff. The tricky playing around with the weird returns is
only
probably did more harm than good. So if we want to talk about something interesting instead and forget about the nonsense
we'll say don't try this at home. And then maybe what we'll do is we'll quickly pop back to, because this all happened for me asking what the lambda function reference was, and you were in the midst of showing us the HashMap code in the
I was. And so if we look at that code, what it does here is let's see if we can find it again. It's up here. So here, again, for any listener, we have a variable that declares a map that keys, where the key is the data type, a symbol describing the data type of a value, and the value is a function reference to the function that is responsible for rendering values of that type. right? So if I want to say render, for example, the function, I have a function called render nil that that renders, because Kap has a null value. So the function render nil, if we look at what it does, all it does is simply return the string null, and this the monadic less than makes it into a two-dimensional array, because you're supposed to when you render a value, you're supposed to return a two-dimensional array of characters. So if I just do less than null or something like this, it will then generate a one row by 3 column from the string, right? But nothing prevents me now from changing the render. So if we do that, so it's called O3. What did I name the variable? I can't even remember. Let's see if we can do that. Here it is. It's called type to formatter. Okay, so type to formatter is a map of 11 values. We can do a map to array and print it. We can see that it maps these types to functions. So we can call the function type of null, and we see that the data type is kept null. So we can update type to formatter. So we see O3 type to formatter, assign from O3 type to formatter, map put Kap null, and then we say test. And now if I want to sorry, it should be a function that returns test. What am I talking about there? Test. And now when I write null, it renders a test as test. So for example, so if you don't like the way the renderer renders a certain data type, you can just update that hash map to create your own function that renders something in a completely different way. And a hash map is, in my opinion, the perfect way to do this. And so that's why it's used. Now, of course, I could have used a plain array and then do a lookup through that. It's fine too. But I don't think there's anything wrong with using a hash map where it makes sense. And yeah, so which brings us all the way back to the reason I'm showing this is to say that I indeed use hash maps when I feel that it's appropriate. And that's really all I wanted to do. The entirety of the message that I wanted to give.
But it's awesome, and also too, like, so all the code we were looking at previously is Kap code, correct?
Yeah.
Yeah. So I mean, it'll be very difficult for the audio listener to have gotten a sense of what it looked like. But there was, you scrolled past some of the stuff in that type to formatter file. But there was some that, had a bunch of dense, I saw some transposes and reverses and stuff in one function. But a lot of the other stuff is, it honestly doesn't look too different than, there's a lot more symbols than you expect to see in Python code and stuff. But in a lot of places, it's just, whether they're variable names or function names or map names, etc. They're like, and that's what I think is, I've mentioned a couple of times, is that there's these honestly like two different worlds of array programming. There's when you're programming quote unquote like in the small, solving these little one-liners, which like I think honestly it's where the elegance of the array languages shine. But then there's real programming, and what we're seeing on our screen right now is actual Kap code, APL code, if you will, and it's not that elegant, dense, completely tacit, a fork here, a B combinator there. it looks like more similar to other code than you would
Yeah.
expect.
Yeah, I think I have some of that. I'm looking for it, but for the most part, I mean, this stuff here might look like a mess, but that's just because the @ sign is the symbol that indicates that what comes after is a character. So this is just the character. So you see this character, comma, append to a bit of an array that is this terminal doesn't render this symbols nicely. This is not supposed to look like this. This is the terminal rendering the font incorrectly. But the point is that this just appends characters. So but it might just look. I think the most. Do I have any of that difficult? I don't have much.
Not really.
I don't know. I don't know.
We'll link all of the files that we've looked at. If you are listening
Yeah.
to this audio only, I'll link in the show notes for folks that want to go take a look. But
There's a fork here, but other than that, there isn't much. So yeah, so my point is that the way this file, I think, is a good representation of the way I would write code, Kap code that is meant for human consumption, rather than code that is meant for execution in the REPL, and I just type it out because I want to compute something quickly. And again, I mean, I'll repeat myself, but what my point here with all of this is that it becomes very easy. When the language has that capability, it becomes easy to solve problems without writing code. I like watching. There's a mathematician that has a YouTube channel that most people would be familiar with. Gosh, what's it? What's his name? The English maths guy that has a great YouTube channel. This is embarrassing. What's his name? Matt Parker. Sorry, Matt Parker's YouTube channel. He tends to use one of two languages when he wants to solve problems, and one is Excel and the other one is Python. And many times have I seen him, demonstrate something in using one of these tools, and I think to myself, look, I could do, it's these 4 characters. You do it with 4 characters in the REPL. Come on, and it's 5-6 lines of Python or a ridiculous amount of copy and pasting to get the value out in Excel. And that's the beauty of it, right? I mean, it's not programming. I mean, a lot of people wouldn't call it programming just because now you're just using a calculator, and that's my point, is that the best use of Kap, definitely, but I think it's true for any of these array languages, is that the true beauty comes when you don't have to program, when the problem is simple enough that you can express it in the REPL directly and just get the result right away. And what really makes it powerful is that a very, very large subset of the problems that you deal with on a day-to-day basis are the kinds of problems that you can solve directly on the REPL without writing a program. And then it doesn't matter that it's unreadable because no one reads it.
I mean, that would be the perfect way to end this episode. And we can end it there if you want. I'm not sure what time, because we were planning, I think, on ending like 5 minutes ago or 4 minutes ago. However, if you have a couple more minutes, do you? Yes, no?
Sure.
We can have one more question, which is just a comment, because I'll once again direct people to Arraycast episode 72, where we talked about this a bit. And there was a great way to segue where you did show that fork. We talked about how the tacit model is different in Kap, and the big thing is that forks are explicit with the characters. And I'll say, if you want to see or hear our whole discussion, because we probably don't have time to rehab that whole discussion, go check out Arraycast episode 72. But the question I'll ask is, how has that affected the feel of programming tacitly? in Kap because it leads to some differences in needing to
Right.
parenthesize things at times, and
Yeah.
it's still the same number of characters a lot of the times, but it does change the feel. And so I'm interested to hear your thoughts on how it changes.
Yeah, I think you're getting at what we touched on in the podcast before, where my whole thesis is that the difference in tacit between Kap and Dyalog results in a tacit expression that tends to look more similar to the non-tacit version of the same code. And I let's. I'm thinking about a good way to
I mean, the simplest example is like if you go 2+, in order to make that tacit in Dyalog APL or in BQN, you have to add the right tac. Whereas in Kap, 2+ is just the tacit expression. That's less because of the forks. That's more because of left-bound functions. If I'm understanding this correct.
I think an even better example actually would be to say, let's say you want to write 1 plus 2 plus 3 plus 4, right? Which is equals to 10. This is a regular plain expression, works in any array languages. Exactly the same code would work in J as well.
Mm-hmm.
Now, if you want to break out the first three numbers, you want to create a function that adds 1 plus 2 plus 3 plus the argument. Now, in Kap, if you want to make this into a function, you just put parentheses around 1 plus 2 plus 3 plus. Right? That is the function. And the reason for that is that 1 plus 2 plus 3 plus is a train of three functions. It's the reading from the right, it is the function 3 plus, which adds 3 to its arguments, chained with 2 plus, chained with 1 plus. Now, if this had been Dyalog or J, then three functions in a row is a fork, right? And that this would end up in being illegal code because the middle function must then be a dyadic function, and the function 2 plus is monadic, so it wouldn't work. But the point is that if you have a chain of functions in Kap, and let's call the functions, I mean, this is not going to make much sense, but we can just use three functions: minus, plus, and what do we pick? A third one. Let's make it into the stars for power, right? Now, if you see these three functions and you read the code from the right, in Kap you would see that, hey, here's a function. It's the star, which means power, right? And you see that, and you know immediately that this is a tacit expression because there is no argument. Now, the only thing I need to look at to determine what is the next thing that is being called is this plus. Actually, it's the thing on the left, but you have to look. You have to see if it's called dyadically. But you don't have to worry about the other arguments. This could be a chain of 15 functions in a row. It doesn't matter. All you have to look at is this. There's no need to count functions, to count even odds that you do in J all the time. You simply read it right to left as you would read any other expression. And you don't have to care what is in the middle. You can work your way through it when and if that matters, right? So we do here. So this would be e to the power of 3, and then plus wouldn't do anything, and then you negate that value, right? Now, what I've come to realize is that in a vast number of cases, if I want to turn an explicit expression, such as the 1 plus 2 plus 3 plus 4, or let's say we have a defun, 1 plus 2 plus 3 plus omega. If I want to turn such a defun into a tacit expression, all I do is remove the braces, remove the omega, and then it's a function. So, and what I also realize is that if you introduce the hook, the left and right hook, a very large number of use cases for the fork goes away. Because very, very often, if you look at your typical Dyalog code, most of the times where you have a fork, the left or the right side is going to be attack.
Right.
And then and that's only because you don't have the hook. So so I consider the 3 functions in a row to make that into a fork is, in my opinion, a little bit of a waste, because now you have this very super valuable syntax with 3 functions. This is the most compact, nice way you can put 3 functions together, and you waste it on a fork, which is not something you use very often, and it causes the functions to be called in backwards order, and all of a sudden you call it the right one first, and then the left one, and then the middle one, just because they happen to be together. So as I mentioned previously, I actually had forks implemented exactly the way, 100% compatible with Dyalog. And I did it mainly because I didn't fully understand Tacit at the time. So I implemented it, based on the APL standard, because I didn't know better. I used it for a while and I could never get comfortable with it. Then I changed the syntax. This one very small change to replace the 3 chain, to make it, it's just a chain of pairs, and make the fork explicit. And all of a sudden, I understood it. It clicked, if you like. I'm not saying everybody is going to have the same experience being faced with my type of Tacit, but it clicked for me. So maybe I'm not the only one. Maybe it could click for someone else, possibly. I just feel that I quite honestly, I mean, there are many things that I've changed for various reasons. In Dyalog. Some of those cases are cases where I believe that the original design was a mistake, such as the circle functions. I honestly do believe the circle functions was a mistake. Other cases is just, I did something in a different way because the parser works differently, so it was more convenient to do it differently. And then you have cases where I made changes because I just feel that it feels better to me. And the fork is one of those cases. It feels better to me. And if it feels better to someone else, great. If not, I'm sorry, uh, I guess.
No need to be
But it is,
sorry.
yeah, but that's the whole point, right? That it is something I think, I believe that if it felt better to me, maybe there are others that feel the same, and maybe that could lead them to be, more positive towards the idea of using Tacit in the first place, because it is something that is difficult to understand, right? It's very, very different from any other language. It's sort of like, I think you named this podcast Tacit Talk because Tacit is one of those things that make these languages very sets them apart. Basically, I don't think, are there any other non-array programming language that has this kind of level of function combinations? I guess. I mean, Haskell has some of it, I
Yeah,
guess,
you can
but
argue Haskell, but it's this kind of like tacit programming. Like I at the point when I realized a couple years ago, several years ago now, that array languages have this tacit programming inside of them, and they're known for their Unicode symbols, and it's read once, or write once, read never, all the jokes around it. But like, not only are they array languages and are they amazing for that reason, but they're also the best languages for tacit programming. Haskell has some support. You could argue that like stack languages like Forth and Factor and Joy, they have some combinator stuff, but you're really just manipulating the stack. You're not actually building up these composition patterns like the hook and the reverse hook and repeated B combinator and stuff like that. And it's extremely elegant. And I think like this example that you've shown, 1 plus 2 plus 3 plus, it's even more amazing than you've marketed it as, because the equivalent in Dyalog APL to get this to work, you have to add the tac after the final plus after the 3. But then, sure, that works in Dyalog APL and in BQN. But the machinery behind what's happening there is incredibly hard to get across in even a YouTube video, because first you have to explain that you have like 3 forks. The first monadic fork forms a unary function that then combines with the second fork to form another unary function, which then combines with the final 1 plus. But then on top of that, like the actual fork that it's this special kind of fork where the left tine isn't a function, it's an array. And that's called like an AGH fork. They call it like that, where the A, capital A, stands for it being an array. So it's not even a function fork. It's like it's a specialized fork where the left tine is an array. And specifically in BQN and APL, there's a limitation where only the left tine can be fixed to an array. You can never have the right tine as an array. And so it's like all of this machinery.
That took me a while to understand. It wasn't until I tried to unpack a Dyalog expression it was some really neat thing that did like something truly beautiful, and I was like, how does this work? And that's when I realized, 3 plus 2 plus, I think it was something like 2 plus minus. And that's when I realized, oh, wait a minute, this is actually a fork. And that's when it clicked. I was wondering, because I was wondering, why didn't they use a jot to bind the 2 with the plus? And I realized that no, it's because it's actually the left side of a fork with the plus in the middle.
Yeah. And that's where you can do crazy things, where if you have a dyadic fork that takes a left and right argument, you can still have the AGH fork, where A is a scalar, and then the 2 outside, the left and right arguments, only apply to the H in that, and then you have the scalar plus the result of that first binary operation. And like, I've studied this stuff for a long time, so I'm able to parse it. But when you compare that to the simplicity of just 3 unary functions, like it's not just that this is so simple, it's that the alternative, and don't get me wrong, I love fork programming, that the way it exists in BQN and Dyalog APL. But this model, I think it's just when I discovered that you had played around with this, and I was like, oh, that's interesting. But then I started messing around with it, and I was like, oh, wait, this combined with left-bound functions plus the hooks, it covers 90% of the cases. And then like it leads to like the repeated unary functions in a row is probably the most common pattern you run into when you're doing tacit programming, and you need the cap in J and the break in BQN, and Dyalog APL doesn't even have something for that. So you just end up using parentheses, or typically the idiomatic thing to do is just put it in braces and an omega and don't do tacit because it's irritating.
Yeah, so I don't want to sit here and somehow claim that the Kap approach is more expressive. To be honest, I do think that you can probably do more clever stuff with Dyalog, but it comes at a cost, and that cost is that it is much harder to understand. And so Kap has chosen to balance it slightly differently. And of course, if you have someone that breathes the Dyalog or J for that matter, every day and knows it inside out, especially these what do they call it, the combinator trains, the new J stuff. It's amazing. It's absolutely crazy when you see people do things with it. It's like it's jaw dropping. I don't understand it. I cannot, I can unpack it. I understand what it does, but when I read it, I have to look up the documentation and then go through, test it. But it is amazing what people do with it. So I think it's a question of balance, right? So the Kap model might not be as expressive, maybe. I think the jury might be still out on that, but that wasn't the primary goal. The primary goal was to make the regular daily vanilla style tacit expressions more aligned with what the corresponding explicit code would look like. And in that, I do think it succeeds better at that. The rest, I mean, people can have different opinions, but I do believe it's for that specific case. I think it did succeed slightly better than what Jay and Dyalog did.
Yeah, I think just for the sake that you have done something different and played around with a different tacit model, that's the thing. I mean, Jay had the hook as the to train, which then Dyalog APL changed later, and I think actually when I was talking to Marshall about I, he did that. So I think technically the I language replaced the to train with not the S but the B, and then Dyalog APL did it, then BQN did it, and like Kap was the first language that actually did something significantly. And that's the thing, is like these array languages are so rare that we don't have a ton of languages that are experimenting with different tacit models, which I'm not saying like everyone should go create an array language and play around with a different tacit model, but I think these tacit models are incredibly elegant when used correctly. And it's like, I think Kai Schmidt, he had a quest for tacit, right? And he's doing something different with the stack.
Yeah.
He had a talk.
Mm-hmm.
If you haven't seen it, I'll link it in the show notes and in the description.
Yeah, I did. Yeah, it's yeah. He has a very different approach.
Yeah.
And I'm impressed. I have to admit, I do think I haven't studied the language well enough, so I am still a little bit baffled. When he explains it, it's like, of course. But then if I want to try to do something myself, it's like, well, how did it work again?
Yeah,
I would love to have him sit next to me and explain to me precisely how to do it, because I felt I knew what I wanted to do, and I wasn't able to express it in a nice way. But it's because it's because I haven't spent enough time learning it. Yeah. But I see there's some really neat stuff in there, and I wish I knew it better.
Well, this is a spoiler for the listener that's made it to the almost 2-hour mark now. But I mean, the goal is that I'm having these one-on-one interviews. We've done Kai with Uiua, we've done BQM with Marshall, and now we've done Kap now. And I think we might have one more. And then the goal is to have like a panel in the future if we can figure out the timing of it, so that I can just bring on all the language implementers, kick my feet back, and then like throw a topic out and then watch the language implementers discuss the pros and cons and the approaches.
Wow. Okay. All right.
I mean, they used to have a talk or a conference called, I think it was called Next Lang or Lang Next. It had like a couple editions back in the early 2010s. And I remember one where the C++, Rust, a couple other languages, all the implementers were there, and they had a panel where they just talked for like an hour. And like those are my favorite conversations, is when implementers get together. And so that's what we're working on.
Yeah, and I do think, quite honestly, I think that within the array programming community, there are plenty of languages. A lot of people do it. I'm certainly one of many that have implemented that. But I do think there is a great deal of mutual respect between the different languages. I think every time I discuss with people like Kai or Marshall or Adam or anyone that has been involved in the design of these languages, there is always, to me, a willingness to listen to the different ideas, right? I don't think anyone has, it's rare to hear anyone run around saying that your idea is garbage, this is how it should be done. So I do think that such a discussion would work quite well.
Yeah. Definitely, there's no C++ versus Rust animosity. Not that all those folks are, but definitely there are. And maybe it's because the array language community is smaller. We know that we're stronger together than we are battling each other. Whereas when you get to the top, it's you're not concerned about the size of the pie anymore. You're just concerned about getting a larger
Yeah, you're not
slice.
worried. I guess you're not worried about alienating people. I don't know. It's. I don't want. I don't. Yeah, I prefer the small community with a lot of respect. I like it.
Yeah.
I've learned so much, especially. I mean, in discussions with all of these people that I've talked to on regular basis. I've learned a lot. I mean, a lot of the ideas, a lot of the things that are implemented in CAP, and we haven't even. There are a million things that we haven't even talked even touched on at all, but a lot of these ideas originate from discussions with these people, right, about how they did it. And then it's like, okay, you did it that way, therefore I will do it this way. The structural under, it's pretty much it's ripped straight out of BQN and then modified to in various ways that I know Marshall I wouldn't say he disagrees with, but he has his reasons for wanting to do it in a different way. But the idea comes from him. The syntax, however, comes from Adam, because he said, "Oh, but I prefer this symbol," and he's like, and I'm like, "Yeah, you're right. This is a better symbol," so I changed it. So yeah, it's a process that is certainly not. These things are not built in a vacuum. And these are a lot of people that are incredibly good at what they do, and I'm happy to steal their ideas.
Well, what do they say? Great artist copy, or no, good artist copy, great artist steal.
Yeah, that's I have that on my fridge as a fridge magnet actually. It was from we bought it at the Picasso Museum in Spain, and so it's attributed to him. But great artist steals, so who knows who actually said it?
Yeah. All right. Well, thank you so much for coming on, Elias. This has been amazing. Like I said, we ended up going 30 minutes longer, and I know it's very late for where you are. We're on
It's just
opposite
midnight.
sides.
It's fine. I'm sharing my screen so everybody sees what time it is and what date it is, and then we
Oh
share
yeah,
this.
yeah, that's true.
So yeah, I
And
can
I
turn off
guess
that
we'll close off by just
presentation.
saying, if folks want to go try Cap out, point them to where they can go download it, get the code if they want to build it. What do you recommend if people want to try it out?
If you just want to try it out, just go to the main page, look for the text Cap in the browser, which runs the web version. And the web version works, it implements almost everything. There are a handful of things that is not there, such as the syntax for Unicode characters with a name. So you could in all the other versions you can type @ Latin uppercase A or whatever the name in Unicode is. This stuff doesn't work in the JavaScript version, and a couple of other things. But the graphics works in the web JavaScript version. Sound works. Graphs and charting works. So you can do, and you can even I found a JavaScript implementation of an Excel parser. So I included that, so you can even load Excel documents into the web version completely without talking. There's no server, so if you want to. So I've actually used it at work for real work stuff. I have an Excel document. I want to calculate some stuff. I couldn't be bothered to start the native version, so I just opened the web browser, loaded the Excel document in there, and did what I needed to do. And secure because it is completely local in the browser. So yeah, that's if you just want to play around, that's definitely the way to go. The other versions also great. If you want to use the Java version, that's where the performance is. Basically, the Java version would be about 20 times faster than JavaScript, but at the end of the day, usually doesn't matter because you have to go get into arrays of millions of elements before you can even notice that.
Right.
So it is certainly the way I would recommend.
And also too, it's been on my list of things to do for a while because you do not exist on Twitter, but you do exist on Mastodon. So if folks want to
Yes.
follow you, is that the best place to go? Is Mastodon?
Yes. And since I'm one of those guys, I think I think Marshall has expressed the same disdain for things like GitHub, um, and mentioned that Codeberg is a better idea, which I agree with. So yeah, I mean, I am not on Twitter because that I prefer to be on a place that is more personal. You can run your own servers, you're in control of your data, etc., the usual. And for the same reason, I'm also the source repository is also in Codeberg for that reason. But this is not the forum to proclaim the greatness of Codeberg versus GitHub. But if anyone is willing to listen, ask me a question and I will rant about it, but I will not push those opinions in people's faces.
Awesome.
But
Well, I will make sure that we've got links on both the podcast and the description down below once this is fully processed. But yeah, once again, thank you for coming on and thank you for taking the extra time. This was absolutely awesome.
yeah, anytime. When you build something like this, you like to talk about it. It's hard to any programming language designer will do anything they can to spend an unlimited amount of time talking about their stuff until their colleagues put earplugs in their ears. Yes, I have. Well, they haven't. They've all. They. I can tell that they want. They're desperately looking for their earplugs when I start to go on about what I'm doing. So, yeah.
Well, I am for one a happy listener, and I'm sure that everyone that's
Thank you.
listening to this on YouTube / on the podcast is as well. Because odds are they didn't make it this far if if they weren't.
You can fast
enthused.
forward. You can put a little note saying if you want to hear a rant, scroll all the way to the end and listen to the rant.
That's true. That's true.
All
All
right.
right.
Yeah.
Till next time. Thank you, Elias.
Yeah. Anytime. Thank you. Bye.